Welcome to BeeGraphy. My name is Asim and today we are starting off with the third intermediate tutorial. We're going to continue from where we left off in the second tutorial, which is the parametric wave design. First of all, let me quickly list down what all we are going to look at. Firstly, we are going to add multiple points, multiple ripples. Okay. So right now we only have one point and then we've got the ripples going out. Now we are going to have multiple ripple points and they're going to interact and create those interference waves in our wall panel. Second, we are looking at dampening. So this concept can also be used in your scripts, any other scripts, just like multiple attractor points is something you can use in other scripts. So I'm going to explain this concept where it's pretty straightforward. If you remember in the last session, I talked about having this panel and then whatever the wall art is. This creates an issue where the edges are undulating. So if we look from the top, it looks like this, something like that. And then the wall art is going down. So what happens is if you want to encase this, which in my case, in my live project, a clinic, we are encasing it between POP molds. So the molds are gonna like be something like this, and they're gonna encase it from top and bottom. But I don't want the wall art to exceed this encasement's extrusion. So to do that, we can dampen this and make it uniform while maintaining the form, the art form below and above. So we'll look at that. Thirdly, we will look at the 2D laser cut files, the laser cut forms or drawings that we need to extract. For that, we will also look at a plugin. So I'll show you how to install plugins in BeeGraphy. How to install plugins. The plugin is Guillotine Nesting. So we'll look at what nesting does, and we'll get the final outcome, which is the 3D as well as 2D laser cut file. But then I'll also show you how to create the 3D 2D toggle that you can flip and then remove the 3D image and just keep the 2D drawings. And if you flip the toggle again, you'll get back the 3D model and remove the drawings from the viewport. I'll give you a glimpse of my original script, which I used for explaining. In this, I've got this multiple points, and I've got two ways of generating them. Either it is random points, or I can keep manual points. You can have more than two, but the positioning is in your hands. I've moved the point which was here to here, but there are 2 points, so we'll see how to create multiple attractor points. Secondly, there is dampening. Like I told you, you see this undulating pattern. All these crests and troughs, the crests would exceed the molds. So if I do turn on the edge dampening, you can see something like this happening. The waves are still maintained, but on all sides we are seeing very nice clean edges. This is a concept that you can use in any other scripts as well. I'll show you how to create this logic. Very simple, just a small script to add. And then the main thing is the 2D model. So the 2D model will look like this. The 2D model is extracted from the 3D, and you can see how I've created these notches, sockets to be inserted in sockets, and I've also numbered each of them so that we know what's the sequence that this needs to be attached. And the nesting plugin that I was talking about, that plugin arranges this in 3 sheets or more, any required number of sheets. You can set the sheet size, everything. I'll explain everything in detail. So yes, let's begin. Let's begin with the multiple attractor point logic. So yeah, and one more thing. So in the part A of this tutorial, which is tutorial number 2, we've got parametric wave design part A. So I'm not gonna work on this script. Otherwise, the people who follow along the second video and click on the link, they'll see the entire thing done and not the script that I taught during the lecture. I'm going to leave this as it is, and I'm going to make a copy of it and rename it part B. And from this, I can see, you see this globe icon. From that, I can see that this was published. So I'll do duplicate, and we are going to rename this as part B and remove this duplicate thing. Awesome. So this is the script that we did in part A, the second tutorial. A quick recap, we've got a number of lures. So if we increase this, we'll increase the number of lures. We can change the number of height. Everything is there. Perfect. We've got this point that goes in distance, which is used as the attractor point. Now, if we take multiple points, so let's take another point. Actually, let me take it along with these range inputs, and then now I've got 2 points, right? This is one point and this is the other point. How do I use both these points in the attractor logic? One intuitive way would be to simply press shift and combine it, but you will instantly see that it does not work. It just takes the whatever the last point you put in as the main input and ignores the first one. In that case, we need to use this closest point, a node called closest point. What this does is it um, it asks for points, multiple points, right? Not just a point, and then we'll have a range of points. Then it identifies what is the closest point. So actually, let's use this grid of points of BeeGraphy's canvas as the base, and I'll sketch it out. Great. Yeah. Let's say this is our workspace. This is the grid of points that we are working with. And then I have 2 attractor points, right? If it was just a single attractor point, it would have been very easy. This point will calculate the distance with all of these points, and we can use that distance to compute. But this point is actually closer to this attractor point, and this is closest to this one. So all these points should ideally consider this distance, and that is what closest point does. It identifies any point. It identifies which point is it closest to, which attractor point is it closest to, this one or this one, and then takes only that value and eliminates the other value, and that is why we get a nice cohesive attractor point logic with multiple points. Yeah, so we are using closest point. Our points, the attractor points go here, and all the base points go here. Okay. It is um, slowing down a bit. So I will reduce the number of points. Yeah, there are so many points. Um, so let's reduce the density. I'm going to reduce the vertical height. We should increase the number of steps vertically, spacing between the vertical points so that it's more spaced out. And we'll decrease the number of lures and increase their spacing. Okay. So I'm trying to reduce the computing time so that we can get to the result much faster. Let's keep this 10 and make this a bit more. All right, let me hide the base points again. And this is much more quicker. How did I identify? Because when I was trying to move the node, it was very glitchy. So, all right. Now, instead of this distance going here, we will have this distance that goes here. It's not visible, so let me increase the number of lures by a bit. Still not visible. So we need to change these values a bit to see if we achieve the outcome. There is too much distortion, so I'm trying to find the sweet spot. I think I've almost reached there. Yeah, I can see that happening very slightly. Let me reduce this. And I want to increase the protrusion that's happening. So let us increase the multiplier. Let's put in 0.15. No, that's not it. So one more way to increase the protrusion is going in the graph mapper and increasing the y value. You see this protrusion popping up. Amazing. So yeah, you can shift these values and find the optimal form. You can see that these 2 points are now creating the ripples. So we have already found one way to input 2 attractor points. Other way would be to create a randomly generated points. So if we put in populate 2D, and we input this rectangle in populate 2D, you will get those points and simply take those points and put it in the closest point node. So I'm not going to do it. I'm going to leave it up to you how to execute that. See, there is some glitch. Let me just refresh the page and that will fix it. All right, that's a task for you. You need to generate the points randomly, generate attractor points randomly in this rectangle. I'll quickly give you a run around. When you create the rectangle, create it on the XY axis and then rotate this entire thing and place it behind this wall. Next, dampening. The idea, the concept of dampening is we are going to create a rectangle and then we are going to do pull point. So we've pulled all these points in front, right? Where is the, just a second, I'm trying to find move. Yeah, all these points have been pulled from a flat surface in front of you. Now what you're going to do is we're going to see how close these points are to the rectangular boundary. Wait, hide. So we are going to create a boundary rectangle, and we are going to ask what is the distance of each point from the boundary. For example, this one has got this much distance. This one has got a lot of distance. This one has got very less distance. So what we are going to say is the lesser the distance, lesser should be the modulation, lesser should be the this move magnitude. So mathematical way to convert this statement is we are going to put a multiplier. This is a big number, let's say 10. This is a small number. So if we have x multiplied by 10 and we have same x multiplied by 1, this will give us a smaller protrusion, whereas this one will give it 10 times larger extrusion. So we are actually gonna go in fractions and make it like 0.1. So if there is any protrusion, make it 10 times even smaller. So there is no undulation. Everything is just the same. You'll understand once we lay out this equation. All right, so I talked about pulling the point and a rectangle. So let's create a rectangle. We will have a rectangle with width and length. The width, let me see how to extract the width. So this is the number of lures, and this is the edge-to-edge spacing. So if we multiply both of them, we will get the width of our wall. Let me see, 609 mm width of wall art. And then we are going to use that and create the rectangle. So that's the width. You can see that it is exceeding by one more space. So we can remove that very quick. An easy way is to just add minus subtraction the edge to edge spacing, and then put in the width here. Oops. And see if that works. No, now it needs to be the thickness needs to be added. So we are going to do that. Where is the thickness? Vertical wall spacing, thickness is somewhere over here. Extrude surface, thickness of plywood. Let's take this value and put in addition. I'm going to do plus, and this thing will go over here, and this thing will go over here. Awesome. You see now it is at the edge. All right, so width of wall art is not that. Let's just rename it back to multiply. This is the width of wall art. Then some cleaning up is needed. Awesome. So we've got the rectangle width. The length will simply be the height of this rectangle, this um, wall art. The height will be vertical points multiplied with the spacing between those vertical points. So I've got that. Let's put it inside length. Now we just need to reorient it in the XZ plane. I'm identifying it from here. So XZ, plane XZ. And we have got the rectangle. Again, an issue. So we need to subtract because this is starting from 0. So we need to subtract 66 from it, or subtract 1 from vertical height. So let's do this. Minus 1. And then put it in A. So now it is perfect. All right, so we've got the rectangle. Now there is a node called pull point. So it gives me the distance between the geometry and all the points. So the geometry will be the rectangle, right? And then the points will be, where are you? Construct point. Oh, this is the attractor point. This is the base points. Yes. So we'll put that over here. Ignore this, what's happening, but we need to just have the distance. We don't need to look at the points. I'm going to hide it. And now this distance will be the multiplier towards this move node. So see, we are multiplying it, we're adding it to create that spacing from the wall. And now we are adding the dampening effect. I'm going to multiply this distance with this outcome, and we'll keep the addition at last. And of course, we need to add another multiplier so that we can reduce this mess. Where are we? Wait. Yes. Now, as you can see, all this multiply, divide is creating a lot of confusion. So we will use a expression, math expression, to fix this. 0.001. So I'll try 0.0. Oh, sorry, 0.01. Let's see what that gives us. Awesome, almost there. But you can see that the dampening has taken place, but the middle part has messed up big time. Let's do this. Awesome. You get the point. Now all that needs to be done on your side is to adjust these values like I am doing, and fix it. But the logic has been applied. So if I keep the original thing intact, this is what we get, all these undulations. And if I use the dampening, you get this softer edges. So when this works, it works great when the art is bigger in size. You'll be able to see those waves much clearer. Right, now we create the 2D laser cutting file. So for that, we need to extract the curves that are being created. We've got points that are running at the back side, which is this base curve, and we've used that to create the surface. So we already have those lines. We've got the top line, bottom line, the wave curves, and also where is the base curve? This one, base curves. So if we join all of them, we get the profile of everything. So let me hide the final outcome. So these profiles, we need to place them, arrange them on the sheets to extract the DWG file. For that, we've got a nesting plugin. To install a plugin, we go back to Workspace. We actually want to go to the main BeeGraphy homepage. Go down, down, down. Look at editor documentation. Here you have all the plugins and simply click on add. Search for nesting and click on add. Now I've added the other ones, imaging, light. Just add them. It does not take any effort. It's just one click. All right, so you've got the nesting plugin downloaded. Go back to your script. And we've got nesting. So when you type in nesting, select this one, nesting bulletin best fit naive. And then it asks for geometries, sheet width, sheet height. So let's just see what happens if I take all these curves and put it over here. So yeah, it does not do it correctly. Nesting is when the geometries are already on X, Y. Right now the geometry is XZ, which is vertical. So it is considering those vertical geometries and trying to place them on the sheet. So that's why it's not working. We need to put all of these things horizontally. So let's rotate them. What would this be? X. Wait. All right, so this is what we'll do. We are going to compress, or we are going to take all of these curves and put it at one point, and then we will simply rotate them. That will fix everything. So let's type in change origin. Change origin moves the geometries to a point, to any point that you like. By default, remember that by default the point is not at the origin. So let's make it 0, 0, 0, and let's take our geometries. This is the lure, what do we say, boundary. So all these lure boundaries will go into the geometry, and they have been called to the origin. Now I'm going to rotate it. Rotate. The vector will be different. I mean, instead of just figuring out, let's just dump in different planes and see what works. Oh, that won't work. Wait, let's try out different values. Perfect. So instead of just thinking work, this one is not what we want. This one is what we want. Now all of these things are flattened onto the base plane. All right, now let's put that in nesting and see what happens. Origin is correct. Some items are larger than the sheet size. So yeah, whenever there is an issue, just click here in this eye icon and it will tell you what's the issue. So we need to simply increase the size of the sheets. Let's take the standard 1200 as the width and 2400 as this, as the length. Now again, what is happening is it is treating each individual lure as a separate entity and using one sheet for each of them because it is all branched. We need to flatten it. Um, and then you put that in geometries, and yes, it works perfectly. Awesome. So we have successfully um, placed all these drawings that will cut out the 3D model for us. Now, there is one more thing left, which is to create those small niches or protrusions for the fixture to happen. For that, I'm going to use this geometry again. We want this base curve. Let's take the base curve, this one. And I'm going to take 2 points on it. So there's point on curve. And what it asks is, yeah, you can see this happening. I'll just demonstrate it, 0.3. Yeah. I mean, without even saying something, I think you will understand that on your own. I'm moving this range input, and that point is moving from end to end, and I'm moving it from 0 to 1. So it's pretty obvious 0.5 will be the middle point of this line. Yeah, pretty straightforward. So I'm going to create 2 protrusions. So let's take one at 0.3 and one at 0.6. And at these points, I'm going to have rectangle. By center, you will see what's happening. We are talking in mm, so let's give it 100. Oh, and we need to change the orientation, which will be xz. So put this point over here and then make this plane go through here. It's not xz, it is yz. Yz. Let's see if that works. Yes, it is working perfectly. And then we are going to have the width also controllable. Now remember, this 40 mm width is not the protrusion, it's half of that. So 20 mm is being protruded outside because it's a rectangle at the center, so it is moving on both sides. And now we're going to eliminate the center line and the right part of the rectangle. And we are going to use that, do that by doing region union. Now, the thing is, to simplify things, we will do what we did here. Instead of doing it in the beginning, we are going to do it at the end when we have laid the geometry down, because right now it is vertical and it might cause issues, and it did cause issues, to be honest, when I tried to do the same thing over here. But this is good for explanation what we are trying to achieve visually, because when we are working on this thing, you won't be able to see much. All right, so let's take all of this. Let's first disconnect it, take all of this, and we would not be using plain YZ, we'll be using XY probably, and find out where we have rotated this one. From this, we are going to extract, we are going to actually explode because we want that baseline. So we are going to explode. And then from these curves, we are going to use list item to extract the curve that we want. Yes, 1 gives you all the base curves, the flat line. And then we are going to use that to create those two rectangles. Awesome. Like I said, we won't be using plane XY. We can use this, but now it has flipped. Let me hide everything else so that you can see things better. Else. Let me unhide this. All right, let me flip these values so that we get the niches longitudinal instead of the way we got it. Now, all these rectangles, we are going to do region union. If you look closely, in region union, what happens is if you have two geometries, use this pointer. If you have two geometries, this and this, region union will give me a geometry which looks like this, right? It has eliminated this part. That's exactly what we want over here. We've got our wavy panels, right? And then we are adding in these rectangles. And if I do region union, all of this will get eliminated. And at the end, we will get the wave and the protrusions only. And that's the desired outcome. So region union, we need to click here, sorry, zoom out, click here, and do add port to get the two regions. So one is are the set of rectangles, and the other one will be the joined geometry, this lower boundary that we joined. This goes in here. Okay. How do we check this? We actually it will be difficult to check it out. So what I'm going to do is simply nest it, and we'll see the outcome. Nest. Wait, do we have nest over here? Yeah. Also, we need to flatten it. So let me take the flatten node with me and put in the region union into it and unhide it. So it is a bit of a mess. We need to fix the data tree to get the correct outcome. So when I'm doing this region union, probably I need to flatten the rectangles also, and then see what happens. Oh, the region union does not work then. Let me quickly check what worked. That's a big script. I probably have forgotten. I tried out many things. I did face the same issues a lot. I tried region, intersection, union, even tried to do the solid intersection stuff. Didn't work out. In my case, I'm doing region union, rectangle by center is grafted, it is not flattened. The rotated geometry is also not flattened, and we flatten it at the end. That's exactly what we are doing right now. Let me check. I'm leaving this troubleshooting here for better understanding how to fix things. So we don't need to flatten, that's for sure. We've got the rectangle by center. Let's just try flipping it. Don't know if that'll work. If I remember, we did rotated geometry and put it over here. Oh, one more thing, probably it's exceeding the thickness. So let me reduce the length of the rectangles. So that was the issue. Awesome. So we need to reduce it even more, I think, because they are intersecting a bit. We're almost there. There is some slight issue that the region union is not working. Let me flip it again and see if that works. Now it works. Awesome. So two things that we learned, even I learned, that even the sequence of regions in region union can change the outcome. And secondly, if the width is exceeding in region union, it the script just gets messed up. So we have achieved the desired outcome. I'll just demonstrate how to control this height of these notches. Did they change? Why isn't it changing? It is changing. Okay. And I will show you the movement of the rectangles. Where is it? The sheet width. A bit difficult navigating around. I'm trying to search for the parameter thing that we did. This one. That will shift these notches up and down. But region union is taking a lot of time to compute and then give the outcome. Awesome. So that is also done. So entire script is done actually. Very quickly, I'll explain the stream filter thing. What's it called? Stream filter. And then there is select, right? Type in stream filter and then type in select. What do we want to flip? Let's say this 3D 2D itself. So we've got the 3D here. I'm going to group it. Type in 3D. Put it down. This entire thing is 2D. Group it up. 2D. Okay. And what we're going to do is, first of all, in select, click on this small arrow down, type in value 1, label 2D, and then click on plus, value 2, label 3D. Just have patience, you'll understand what will happen. On the right hand side, whatever you write, that is what will pop up in your drop down list. And on the left hand side is what will be the output from here. Let me show you. If I select 2D, you get 1 because this is the associated value. And if I click on 3D, you get 2 because this is the associated value. If I put in some other number, we will get that number. Now, why do I need 1 and 2? Because in stream filter, we've got 1 and 2. In stream filter, what happens is you can put in any input in one of these things and any other input in one of these things. In this, the input can be anything. It can be any geometry or number, anything. And then there will be an output. The gate select will go into the gate, Um, and then it is showing me an error because index is out of bound, because this is a string that is going inside. String means letter. So an integer is a number, but string is a letter. So we need to convert string to number. You see this icon, ABC and 1, 2, 3. So if it is this, then it should work. Wait, what if I do directly? Oh, okay. So you don't need to worry about that. What had actually happened was, you remember in the previous one, I just type in 2, 3, 4, 5, 6, big number. That was the input that it hadn't refreshed. So that was the input that was going inside, and you're getting the error. So just ignore what I said about string and um, numbers. So yeah, if you put in 2D, 2D means 1 is going in this gate, and then it is selecting only whatever is coming inside 1, which is 4 in this case, and we are getting out 4. Then if I click on 3D, it is taking 2 as the value, which goes in and then reads 2 and takes in 6. So by that logic, you can already figure out you can add more gates, more drop down items, in which case you will add more ports and so on. Okay, remove port. So now whatever works for 2D will go in 1. I'm gonna put this at a strategic location that will make the script run. I'm trying to look for something simple. I think I can just take this, put it here, and this goes over here. The thing is, this will work, but I don't want this region union to be running in the background because it is slowing down the script. Like even if you want to look at the 3D part, this region union will slow everything down. I'm gonna place it somewhere earlier. Let's say over here. This geometry goes in 1 and then it goes out here. So it is going through this thing. When I click on 2D, it starts working and it gives you the output. Okay, so there's an issue that this is not working. What shall we do? Let's use this and this. See if it works. Oh, this is not connected. Still not working. Let me just refresh it and see if it works. Because everything is the same. The data is just flowing through the stream filter. Still doesn't work. All right, let's place this at last, which I did not want to do, but I think this is happening because everything is grafted. So we need to fix the data tree before continuing. All right, so we have got the final outcome. It's just a small glitch. Script is exactly the same. We've got the point on curve, we got the rectangles, everything is nicely branched. And then the region union is done. Sometimes if there is an issue, what you can do is simplify tree, make it go through this, and that will fix it. But in my case, even if I'm not doing it, it's still the same. And for using the stream filter and the select, we'll quickly give it value 2D, 3D, taken 2D, put it over here, and let's take these values and put it in explode. See what happens. So I think it is working. Let's flip to 3D and see. Perfect. Let's go back to 2D. It's working. When you go to 3D, it gets no values. And when we are in 2D, it is correct. So when we flip to 3D, the 3D part should work. What I'm going to do is go to 3D, see where it begins here. I'm going to create a stream filter here, and we'll place this in 2 and put it here, and the select goes in this stream filter. So when we tap in 3D, the 2D will turn off and the 3D will initiate, and we get the 3D file. Let me hide everything. All right, so that is how you create the stream filters. I'm trying to hide these lines. Awesome. And also the input points. If you remember, I asked you to create multiple points through populate node. All right, so same thing can be done with edge dampening. And one more thing that I wanted to demonstrate was the math expression. Here you can type in anything you like 20 plus x, and then whatever you put into x, you'll get the outcome. So all the values that are going in have been added by 20. In this case, we get the answer as 24. So you can make it more complicated, where instead of spacing from wall is going into this thing, you can put plus a, which will be the spacing of wall, and then you add port and rename it to a, and then take this value inside, and x would be whatever is going inside this addition, and then the output will go in the vector y. I can remove this addition, and then this math expression is working like this. So the a value is increasing to give you the spacing from wall. Same thing, you can multiply this entire thing by a certain amount multiplied by 0.5. So it has halfened, all the lengths have halfened. Minor glitch, let me refresh it. Yeah, perfect. So you see where I'm heading towards. Instead of 0.5, you can have another variable called y, and then that y, you can have a range input going into that math expression. Awesome. So play with this. 1.2, more prominent. Play with this, change this math expression. I'm going to leave the script like this, very raw. We've got 2D, we've got 3D, we've got these stream filters running. I'm going to leave it outside so you can see. And then let me rename a few more things. This entire chunk is creating the ripple. So let me call it the ripple algorithm. And yeah, these are the ripple origination points. Ripple, let's say just points. Yes, and everything else is just adjusting the wall size. All right, so I hope you found this useful. You followed along. Um, keep in mind the dampening concept that you can use for your own scripts. The multiple attractor logic, instead of distance, we used closest point. So remember that. For 2D, you saw what we did. We extracted the curves. Um, we did change origin to put all of them at one point, oriented it in XY plane, and use nesting guillotine. We saw how to use these trim filters. You see this one is in 1. When I click on 2D, this thing gets turned on because 1 has got something going in, 2 has nothing. And in this case, 1 has got nothing going in, and 2 has got this input. And this is how it works. To unhide the geometry, you see this error pop up. Simply do simplify tree. No, simplify it here, rectangles, and it works just fine. All right, that is all for this second to third tutorial, and hope to see you in the next one.